Hi, I'm Farah Diana binti Zainuddin with metric number F210084. We are from Group 2. Today, we are going to present about our project in subject Engineering Mathematics 1. In this project, we need to create one problem in civil engineering. The problem's created could be solved using engineering mathematics which is learned in BFC 25013. In this video, we are going to talk about rate of change in Newton's law of cooling. A second-order differential equation is a differential equation that consists of a function and it's a second-order derivative. A second-order differential equation is written as y double prime plus px prime plus qxy is equal to fx, where px, qx, and fx are function of x. If fx is not equal to the zero function and px, qx are function of x, it is expressed as y double prime plus pxy prime plus qxy is equal to fx, which is non-homogeneous second-order differential equation. So, we use the application of second-order differential equation to determine the rate of change in Newton's law of cooling in the curing process.
In Chapter 2, we are discussing about the development of Villa table. In engineering, we know that the curing period depends upon the type of cement used, mixture proportions, required strength, size and shape of member, ambient weather, future exposure condition, and method of curing. Since all desirable properties are improved with curing, the period should be as long as practical. For most concrete structure, the curing period at temperature above 5 degrees Celsius should be minimum of 7 days until 70% of the specified compressive or flexural strength is attained. The period can be reduced to 3 days if high early strength concrete is used and the temperature is above 10 degrees Celsius. And for the Villa table, we prepared 3 facts with ideas, learning issues, and action. The first fact is concrete curing. The idea is need to find the Newton's law of cooling with learning issues how to determine the equation by using Newton's law of cooling formula. So the action that we have taken is we created the equation by using the stated formula. And the second fact is temperature and time. The idea is need to integrate and separating the variable in order to find the temperature and time. The learning issue in this fact is how to determine the t in k and time. So the action that we have taken also, we apply the integration to determine the t after separating variables and then substitute in the value of t into the equation that we have get so that we get the value of a. Then we find the value of time t using the stated equation. The third fact is heat transfer surface area. We need to substitute the related value to find the value of A. So, the learning issue is how to determine the T in Newton's law of cooling. Then the action that we have taken is we substitute the value of T into the equation. Then we get the value of A, which is the value of heat transfer surface area.
Next, methodology part will be presented by me, Professor Kamaruzain. So in this part, firstly, we did with some research, meaning and method by doing some research. By doing some research, we express it in the word, mostly understandable with concept, which is curing is chemical or physical process that result in a stronger firm or more durable concept or material, such as a concrete. So by repairing defect might lead to structural deterioration and its consequent to calculate the rate of change in temperature at a single site. At a single site, Newton's law of cooling must be employed. The Newton of cooling is based on differential equation dy over dt equal to kt minus y, where yt is the temperature of the object and T is the temperature of surrounding environment. The rate at which the object dy over dt should be proportional to how much cooler the surrounding than the object. So dy over dt should be proportional to the difference in temperature T minus y. In other words, we should have this equation where K bigger than 0 is a constant proportionality. This different equation is easily solved by separating by follows.
Thank you. So now I will present the solution of the project. So we are using Newton law of cooling formula for calculate to get the result of the calculation. So we submit the value into the formula. So the information from the equation, we get water temperature 15 Celsius, initial temperature of concrete 77 Celsius. Next, we get temperature difference between concrete and fluid, time and positive constant. According to the calculation, the concrete must reach its ideal temperature for cooling during the curing process in 27 minutes.
Thank you, Muhammad Adha. My name is Muhammad Qayyum bin Razman and I will continue our discussion. Firstly, we determine the equation by using the Newton law of cooling formula for the curing process. And number two, we apply the integration to determine the T, which is temperature, after separating variables and then substitute the value of T into the equation, then we get the value of A, which is heat transfer surface area. And number three, the rate of cooling during the curing process using Newton law of cooling is directly proportional to the different temperature between the concrete and the surrounding. The temperature of the surface curing depends upon the strength of the draft of the air. From the calculation, it shows that the higher the initial temperature of concrete, the more time taken to get the optimum temperature for cooling the curing process. And number four, the Newton law of cooling is useful for studying things such as water heating because it can show how fast the hot water in pipes cools off. It also shows that the practical application is how fast a water heater cools down if you turn off the breaker. Lastly, we can conclude that the concrete reached its ideal temperature for cooling during the curing process is 27 minutes and below in 1 hour. Lastly, last but not least, I will pass this presentation to Muhammad Naim to continue our presentation. Thank you.
Now for chapter 6, conclusion. As a conclusion, the curing process of concrete is a very important thing to be understood as an engineering student. Curing process is a process in which the concrete is protected from loss of moisture and kept within a reasonable temperature range. Curing process will help in increasing the strength of the concrete and decreasing the permeability of the concrete. Curing process can be in chemical reaction and physically action. In this project, we use the second order differential to derive the equation to determine the rate of change in the curing process using Newton's law of cooling. Newton's law of cooling states that the rate of heat loss of a body is directly proportional to the difference in the temperature between the body and its environment. In the calculation, we successfully determined the time taken for the concrete slab to reach its ideal temperature for cooling by considering the temperature of the concrete slab and the water temperature.